Hello everyone and Bangkit team who are watching this video presentation. This is our capstone project by the name is Bin Grader and the ID is C23-PS128. Before we begin, I want to introduce all of my team members in this team. The first one is our leader. His name is Fauzan Akmal from Machine Learning. The second one is Aigraslia Hutagaul from Machine Learning. The third is Azali Parabi from Machine Learning. The fourth is Muhammad Farid from Cloud Computing. The fifth is Ahmad Nur Yasin from Cloud Computing. And the last one is Rahmat Nur Ihsan from Mobile Developer. Alright, for the next 10 minutes, we will talk about the first is the background of this case. The second one is idea selection. The third is data and the modeling. The fourth is the API. The fifth is the cloud architect. Sixth is mockup. The seventh is the implementation of our model, and the last one is the business pitch. Alright, let's begin. This is based on the USDA data, or United States Department of Agriculture, in the ASEAN region. Said in 2015, Indonesia is the second largest coffee producer and exporter after Vietnam. And the determination of the moisture content of coffee beans is one of the benchmarks for the drying process in order to obtain good product quality and low drying costs. At the storage, coffee beans need to dry until they reach water content or moisture value. It's about 12%. And measurement of the moisture content of coffee beans is generally carried out using two methods. The first one is thermography or oven method that was found in 1984, and the last one is conduct metric. The first method, or the oven method, requires special preparation of the sample, so it takes quite a long time. And for this complaint, we want to make an application to help coffee bean farmers detect the moisture of coffee beans. And this is hoping is that the Bin Grader application will make it easier for farmers to predict the moisture, and of course will reduce the production price. Alright, as I mentioned earlier, this is the visualization of the number of Indonesian in the second position after Vietnam. Indonesia is the second position, but the number of production is about 668.677 in ASEAN region. Alright, based on the background, the idea selection is we have the case is to detect the moisture, but for the detect the moisture we have some constraints. We need many features to detect this. Means that if we see the right side of the visualization, we see that the moisture has some pattern. Means that based on the visualization, the moisture is not separate even though its continuous value. So because of this pattern, this value could be set into classification. The conclusion is this moisture is continuous value, but because it has pattern at the value, so we can use classification method to detect the moisture. Means this classification method will we use to predict the moisture value. Alright.
Okay, next is data and model. This is our dataset. Here's our link of dataset. This dataset is from GitHub, consists of train, poll, and test data, and has 5 labels. All copies are photographed with different combination of brightness, saturation, and blur. We can see in this screen, this is our data preparation. The first, we do pre-processing the image. We input the train, the validation and test data. After that, we training the train set, the file set, and test set, and we found there's a lot of image from 5 classes. We can see the labels in the screen.
Alright, and here it is for the model that we use in our application to predict the moisture of coffee beans. We use triple deep convolutional neural network from TensorFlow, such as DenseNet 1-to-1, Inception V3, and VGG16. For the first model that we use in DenseNet is DenseNet 1-to-1. We define the model first, and then we call the function and input it to variable that name is model1. And the second model that we use is Inception V3. Like before, we define the variable first, and then we call the function and input it to variable that name is model2. But in this model, we also use fine-tuning. Fine-tuning is the process in which parameters of a model must be adjusted very precisely in order to fit with certain observations. And the last one is VGG16. Same like before, we define the model first, and then we call the function and input it to variable that name is model3. After that, we fusion the models that include the model 1, model 2, and model 3 that we defined earlier to the array. And we declare the variable outputs from our models and the variable y for the average of our outputs variable. And then we define the variable named TDCNN, that means triple deep convolutional neural networks that use model function from TensorFlow to grouping layers into an object with training or inference feature. And then don't forget to compile and training the model. Next. After we train, we get the accuracy, loss, failed accuracy, and fall loss. As we see in the graph, in the screen on the left, we get 40% for train loss and 98% for the accuracy. And in the right side, we can see the confusion matrix of our model.
For the second part is a cloud computing part. The first of all, the API and the dependency. First, we use Express as the REST API service based on JavaScript. We use it for backend. The second one is Flash REST API service. We use it for model based on Python. And for the save model, we use .h5 file. And for Google Cloud Platform, we use App Engine, Google Compute Engine, also Google Cloud Storage and Container Registry. We use that for image builder. And then for test our API, we use Postman as a API client tester.
This is a cloud architecture. First, we use identity platform service to authenticate and manage user data. We are deploying static content API built with Node.js using App Engine on port 8000 and deploying machine learning API built with Flash using Compute Engine on port 80x0. We said that we also use a bucket from cloud storage service to store image from the scan result.
In making the application, we use several resources: Material Tree for display design, Jetpack Compose to create application UI, Camera X to take photo for detection, Firebase for login and register, and Lottie for animation in onboarding. And here is the application view on home. Then on the scan page, we will select the photo of the coffee beans we want to detect either from the camera or gallery. Then after the photo is successfully processed, the application will display the quality of the coffee beans.
This is our business page. The first is segmentation. Age range is 30 to 50. The profession is farmer. The roles is owner's coffee field and specific attribute is growth, crops, and selling. And the second user is from 30 to 60 years old. The profession is factory owner. The roles is coffee manager and the specific attributes is manage coffee.
This is the roadmap that we have prepared. The first point is the initial launch. The first subpoint of the initial launch is the Google Play Store page. And the second subpoint is the website. The second list consists of the feature to be added. The first subpoint is to improve the accuracy of the model for the classification of the coffee bean quality by adding more data. And the second subpoint is the detect of the water content, shape, and type of coffee bean. The next subpoint is the recommendation for pre-processed coffee bean. And finally, electronic commerce. The third list is the about partnership with regional coffee farmer organization. And the last list is the massive launch.
And this is the project milestone for our application in 2023. On July, we initial cloud launch. For Bean Grader will be deployed as a whole and available for download. And on August, the app feature is updated. Our application will be better coffee bean scanning accuracy and recommendation for processed coffee beans. And on October, for detection update, can detect the water content, shape, and type of coffee beans. And on December, the grand launch for a complete launch with streamlined feature, a fully working application.
For budgeting, we have two versions. The version 1 is on total will be $5,000 or 70 million rupiah. And for version 2, the total will be $10,000 or 140 million rupiah.
Alright, that's all from our Bean Grader. Thank you for your attention in this video, and we will say sorry if our presentation is not satisfying you. Thank you.